This is part 1 of Unit 5, Lesson 5, Curve Sketching. What we're going to do now is we are going to look at all the different analysis we've done throughout this unit to specify whether we have an increasing or decreasing function, where our relative extrema are, where our concavity changes, and we're going to put that all together to see if we can sketch the curve. So on top of that, we are also going to need to think about the intercepts, any asymptotes, whether they're vertical, horizontal, or the range of the function. So just to introduce this, we're going to do a quick little review here of how the signs of the first and second derivative affect the general shape of the curve. So starting with the first two entries where our second derivative is greater than 0, we want to relate that to where the first derivative is positive. So what we know is that in the case where f double prime is greater than 0, we're going to be concave up, and we're going to be increasing with a positive first derivative. So putting those together means we're on this part of the curve, like that. And then the only difference when f prime is less than 0, we're still concave up, will be on the other side of a concave up curve. So it'll be on this side. So we have a decreasing function, but we're still concave up. Now let's look at the two options when the second derivative is less than 0. So that means we would be in a concave down situation. But if our first derivative is positive, we are still increasing. So we'll be on the first side of that concave up shape. And then when the function is decreasing, when the first derivative is less than 0, we're still concave down, we're going to be on the other side of that concave down shape. So things to think about as you're sketching your graph. Okay, so what we're going to do is we are going to try to sketch a graph when we're given all of these conditions for g of x. So the first thing we're told is that g prime of x is positive from negative infinity to negative 1, and then again from 3 to infinity, and f prime is less than 0 on negative 1 to 3. So what I know is if I add some things to my graph here, is that at negative 1, before negative 1, the function is going to be increasing because the derivative is positive, and after 3, the derivative is also going to be increasing because the derivative is positive. But in between those 2 points, the derivative is going to be negative. Okay, that also tells me something about those 2 points. They're going to be my relative extrema because the derivative will change signs, and the function is going to change from increasing to decreasing. The second condition that we know is that the second derivative is positive from negative infinity to negative 3, so I'll add that point. And then it's also positive from negative 1 to 3, and then it's negative from negative 3 to negative 1, and also from 3 to 0. So now I've also identified my inflection points at negative 3, negative 1, and 3, because that's where it's going to change its concavity. And then finally, we're given a little bit of information about the end behavior of the function. First, that g of x is negative 4 as x approaches negative infinity, and g of x is positive 4 as x approaches positive infinity. Okay, so we are ready to go here. I'm going to add some things. I'm going to put my horizontal asymptote here. I actually don't need this side. Whoops. Of this one, and I don't need that side of that one. Okay, so using the first set of information, we know that, let me just add some other points here. We said we had a point of inflection at negative 3. So this function is going to come along this asymptote, and it's going to change concavity somewhere here around negative 3. So what I want to see is that it is concave up here. So it's going to come up like this. And then from negative 3 to negative 1, it's going to be concave down. And I also know that at negative 1, I'm going to have a relative maximum because this function is increasing up to that point and then decreasing after it. So here at -3, I'm changing my concavity to be like that. So I'm concave out now. I'm going to make this one a little more obvious that I'm concave up instead of concave down. There. If I can meet the point. There we go. Make my point bigger. And then, so I have my maximum at 1, and then at 1 what happens is the concavity changes to be concave up again from -1 to 3. And I also know that at 3 I am going to have a relative min for the same reason. I'm positive between 3 and infinity, but negative before that. So this function is going to come down kind of like this. So it's concave down, and then it switches over to concave up here like that. Okay? So that's a rough sketch of our graph using all the information given. Okay. At the top of the next page is just a refresher of some of the symbolism we used to help us figure out what is happening with the function, whether it's concave up or down, whether the function is increasing or decreasing, and whether the derivatives are negative or positive. So we're going to use a little bit of that in the next problem. So example 3 says that we are given the derivative graph of f, and so can we sketch f from what's given? So let's talk about what we know, and you want to keep track of the fact that this is the derivative, it's not the actual graph. So two things that I have here. Let me call this point A, even though I missed it. The 0 there I'm going to call A, and the other 0 I'll call B. Those are going to be my extrema. So the zeros of f prime may be the extrema of f, because that's where f prime of x equals 0. So I'm going to make a first derivative chart here. So I have f prime, and I have f, and then at point A and point B here. So before point A, the derivative is positive, so that means the function is going to be increasing. Between A and B, the function, the derivative is negative, so that means the function will be decreasing. And after point B, the derivative is positive, so the function will be increasing. Okay, so extrema of f prime then are going to be possible inflection points. The extrema of f prime. All right, so let me erase this. And so what we're talking about is this point. Here we have a minimum where we're going to have a 0 tangent line. So this is a possible inflection point. So let's see what's happening before and after that inflection point. So let's do our f double prime sign chart. So we only have one point, and that's at x equals 0. So before that, the slope of that line is negative, so the second derivative will be negative there. So that means we're going to be concave down. And after that point, the curve is looking up that way, so the second derivative will be positive because the slope of that part of the curve would be positive. So we're going to be concave up. Okay. So now, when f prime is above the x-axis, then f of x is increasing, as we said. And when f prime is below the x-axis, then f of x is decreasing. So if f prime is increasing, then f double prime is greater than 0. So f of x is concave up. We're just putting in words what we put in our sign charts. And then number 6 says, if f prime is decreasing, then f double prime is less than 0, so f of x is concave down. So let's put this all together on our picture. I'll erase some of that stuff I have there. All right, so using our sign chart here, oh, I should have left the A and B there. I'll put them back. we know that we have a relative max somewhere up here. That's going to be our max. And we have a minimum somewhere down here. And we also know that we are concave down before that. So we're going to be like this. And then we have an inflection point about halfway here. So like there at 0, where the function is going to turn over here and become more concave down. That is a really crappy little drawing there. It's hard to do this with a stylus. There we go. And then it turns back around and comes up like this. So there is our function based on the derivative. Okay, next example. We are going to connect the first and second derivative to the original function based on a picture. So for example 4, we have 3 parts to it. Part A is we're going to assume this picture is the function. Part B, we're going to assume it's the derivative. And for part C, we're going to assume it's the second derivative and answer these questions about it. Okay, so looking at the graph of the function, our first question asks, on what open intervals is f of x both increasing and concave up? So increasing, it's concave up here around -5, and it's increasing there. And it's also doing that from 4 to 6. We would have a positive tangent line there, and the graph is concave up. So I would put for number 1 from -5 to -2, and also from 4 to 6. Okay, next question. On what open intervals is f both increasing and concave down? So f is decreasing and concave down. So we have that just at one place, and that would be from that -1 to here. We're concave down, and we would have a negative slope for the tangent line there. So just from -1 to 2. And then the next part asks, at what x values does f have inflection points? So we want to look at where the concavity is changing. So we have one point here where we're concave up, and then at -2 we flip over. And then that happens again here. We're concave down till we get to 2, and then we flip over again. And then finally the last point would be here at 6. We're concave up, and then it flips over at 6. Okay, so that's just reading the graph directly. So the next part asks to assume that this picture is the derivative, and we are to answer these 4 questions. So you guys have your notes in front of you. I'm not going to keep swinging back and forth. I'll answer all the questions and then write them down. So number 1 says, on what open intervals is f of x decreasing, and justify your answer. So you want to remember now that this is now the derivative of the function. So we're looking where the derivative would be less than 0. So that would be right here in this section. Here f prime of x is less than 0. So f of x would be decreasing. That's part A, or number 1. Number 2 says, at what x values does f of x have a local minimum, and justify? And the only place that happens is here at 2. Even though there are 3 zeros at -5 and 6 as well, this is the only place where we're going from a positive value here to a negative value there for the derivative, so that would make it a maximum. And then 3 says, on what open intervals is f of x concave down, and justify? So what we're looking for on the derivative is concave down, we want a negative slope, and we also want that f prime is decreasing. So that happens in 2 places here. Right here we have a negative slope, and we have f prime is decreasing. And we also have that from -1 to clear over to 4 here. Okay? So that would be the other place that that happens. Let me write those two down before we get too far away from those. All right, so part A, we said that what intervals are we decreasing? Just from 2 to 6, and our reasoning would be that f prime of x is less than 0. Where do we have our local maximum? That was at x equals 2, and our reasoning would be f prime of x changes sign from positive to negative. And then the last part, on what open intervals is f of x concave down? Justify. We had 2 of those. That was -8 to -5, and also from -1 to 4. And our reasoning would be because f double prime of x would be less than 0, and f prime of x is decreasing. Okay, now the last question, at what x values does f have an inflection point and justify? So we have 3 inflection points in this graph, if this is our derivative. Those inflection points are going to be the zeros of the derivative. So that would be at -5, 2, and 6. Oh, I'm sorry. I keep forgetting what graph I'm looking at. This is the derivative. So I need to have zeros of this derivative. So it's going to be here where I have a horizontal tangent line at -5, here at -1, and here at 4. Okay? And so let me write that down along with my reasoning is that my f prime, f double prime would be 0, and also the derivative is changing sign from this derivative would be negative, this would be positive, and then we go positive to negative, and then negative to positive. Okay, so writing that down, I have my inflection points would be at x equals -5, x equals -1, and x equals 4. And my reasoning would be that f double prime of x would equal 0, and f double prime changes sign from positive to negative, or negative to positive. Okay, now we're going to assume that this graph is the second derivative and answer these 2 questions. So my 2 questions are, on what open intervals is f of x concave down? And at what x values does x have an inflection point? Okay, so let's take a look at the graph here again. And now this is going to be our f double prime. So the first question was, on what open intervals is f of x concave down? And there's only going to be one interval. That's when f double prime is negative. So that would be this interval right there, from 2 to 6. Here, the second derivative is less than 0. So that is the only place that it would be concave down. And then where would the inflection points be? Those would be here at 2 and 6, not at -5, because 2 and 6, we have the idea that before the point we have a positive value, and after the point we have a negative. And at 6, it's the opposite. We start out negative for the second derivative, and we switch to positive. That doesn't happen at -5. We start out positive, and we stay positive. So let's put the answers for those 2 questions. So number 1 was what open interval? That was from 2 to 6. And our reasoning was that the second derivative was less than 0. And we had 2 inflection points. They were at x equals 2 and x equals 6. And our reasoning is that f double prime changes signs from positive to negative, or negative to positive. Okay, I'm going to stop with this problem, and then we'll continue our discussion of curve sketching in part 2 of this video.